What is up, ladies and gentlemen? Welcome back to Tribune. Today, we're going to be bringing you a special TikTok edition. Let's go ahead and see if we can flat smack a folk or two. Here we go.
Had a very accurate astrology using the pyramids, and I was kind of like, yeah, but they also believe that, mummies could get resurrected after a certain time. Where are these mummies at? Can we talk to these Egyptian mummies? I was just kind of trolling them because I was like...
I mean, I don't know. With Cajun though, he's the person, like, every single time I'll like back him into a corner, and it's like the only thing he could possibly answer with is the answer that he knows is right, like gravity or something like that. And then he changes topic. He's like, you know what? You're just a dumbass. You're too young. You haven't lived enough life. It's like, you see, like, you can't answer a simple question, so you start freaking the fuck out. And then he thinks I'm being disrespectful because I'm like, no, let's just stay on topic. You can't just pelt me with more questions and not answer the one I just asked. It's like, we need to stay on topic.
Well, that's kind of the discussion I keep wanting to have. It's very nuanced and very basic, but it's like, I was trying to show him a bunch of books. I was like, look, if you want to disprove, it's like, fine, you don't believe the math, but here's the thing: the math is logically consistent. It builds upon have some power and influence over our environment from what we've discovered and what we can do. So I was kind of like, I was going to propose, well, I'm going to propose, I'm like, can you, without using any of the math and science that you claim is wrong or incorrect, or that you don't trust, that you say we're indoctrinated with, can you build a computer without using any of this stuff? Can you build a computer?
Right. Well, you have to understand though, those are the same people that go up to like a 5G tower and they're like, look, there's radiation coming off of it. No shit. What did you think it was? You thought it was magic unicorn rays? How else did you think it worked?
Well, a lot of people was like, 5G is dangerous. I was like, 5G exists between radio waves and visible light. So which so which is more dangerous? The radio waves that you play through your play through the car tuner, or the visible light that you see? It's like, 5G exists between there. So
well, there are people who are like, oh, I lived near a tower and I started getting headaches. It's like, dude, no, you're placeboing yourself into getting a fucking headache. It's like, because I live literally right down the street from one. Nobody I know has any problems. None of that shit has ever fucking happened to any of us. I asked all the people who live around me, like, whenever I talk to them, I told them about, like, the dumb conspiracy people I talk to, and I'm like, what do you think about 5G towers? They're like, oh, those people are dumb. It's like, there's the one down the street. It does nothing. We're all fine.
And people don't realize, like, there has to be more 5G towers because the signal don't travel as far. So it's like, so you have to plant more 5G towers in order to have like a very, consistent mesh.
Right. And I always wondered, why does your phone signal stop working when you're in the middle of the ocean? It's almost like there's something going on there. Maybe perhaps could it be something is blocking that signal from getting to you? Perhaps the curvature of the Earth, maybe?
Probably. That might be why satellites are very needed.
Yeah.
Right? Yeah. Like, I wonder if satellites are fake. Why? How come you can't use your normal phone at sea, but you can use a sat phone? It's weird. Yeah. Wonder what's going on there.
An old school satellite.
Laid on your back and looked up at night. Where are the thousands of satellites that's orbiting? I was like, how visible do you think a truck flying in outer spaces would be at night?
Right.
Yeah.
Oh wait, here we go. They said, we have never been to the moon, in response to all that beautiful, change of topics there. If you'd like to come in, if you have enough followers, you don't, sadly. Well, I was going to say you could come in here and try to prove your point, but you can't.
Yeah, let me know. I can hop out if somebody wants to.
Is fake. NASA is fake, like the organization.
I never understood the section with NASA because I'm like, you don't need NASA to talk about any of this stuff, you know.
By the way, if any flat earthers want to come in, you can request like that.
Yeah.
I'm more than happy to let someone go. I just need someone to request.
I've been to NASA and met many people there, and they're all just gigantic nerds.
If Flat Earth Drew comes in, I'll drop.
All right. All right. Does someone want to drop so I can let this person in?
Yeah.
I'll drop.
All right.
All right. Whoever wants to is fine. Up to you guys.
I'm dropping.
All right.
Hey, how's it going? Appreciate you having me on.
Wait, Globeman, before he starts, are you not able to accept 4 people?
No, I don't think I can. I could try. Let's see.
I know a lot of people have that privilege for some reason.
Yeah, I don't have that yet.
Can y'all hear me?
Sorry.
Yeah, we can hear you. What's going on?
Okay, awesome. Sorry, I'm new to this. I just got the 1,000 followers, so appreciate y'all giving me a platform.
Congratulations.
Awesome. But anyway, I'm going to be honest with you. I kind of just hopped in. I didn't hear a lot of what y'all guys were saying, but it seems like y'all are pretty confident in your belief. So I was wondering if any of y'all knew about the 3 Bitcoin challenge that's floating around right now.
Yeah, by David Weiss. It's kind of a red herring because his only stipulation he had is that he has to be convinced. So all he has to say is that he's not convinced. So I don't know. It's kind of a fake challenge.
No, it's actually a very real challenge. You just have to prove it scientifically, which means it has to be observable, repeatable, and it has to be something that can't be bullshitted or something that you can't just send over data. I'm sure you guys, since you know about all this stuff, you've probably heard the argument that NASA even admitted that the simulations that they ran with the data were so intense that nobody was able to tell the difference between that and the real thing. So this whole idea that it takes thousands of people to be in on it for it to be legitimate is just absolutely preposterous. Anybody who's worked in the corporate world knows about compartmentalization. The employee at Walmart does not know what the manager is doing, even though the employees are doing most of the work on the ground. So nobody ever sees space. That's just an absolute fact. You can say that, well, astronauts go up there and send pictures down, and that's anecdotal at best. You can't actually verify that those are actually real. So when it comes down to the actual terrestrial experiments, they show conclusively by the actual cosmologists and physicists that are in the field, they say that the experiments show that we're at least not moving, and we don't like that presupposition. We have to avoid the horror of a unique position in the universe. I was just wondering what you guys thought about that, if you thought that there was any kind of bias in that statement, or if you think that everything's on the up and up.
So it is very easy to prove the rotation of the Earth. That is absolutely no problem. As for the motion around the sun, we have to look outside of our reference frame, right? Like just looking at the Earth, there's no way to tell it's moving around the sun. We have to look outside of it.
Let's touch on that one point at a time, right? So you say we can prove the rotation of the Earth extremely easily. What is your proof that the Earth rotates?
Yeah, so the easiest one that anyone can repeat would just be a pendulum. You can actually see the rate at which it precesses.
Okay, so you're referring to Coriolis Effect?
It will act accordingly with the Coriolis Effect, yes. But,
okay.
Yeah, it's
so
be the rate that is more so, though.
Okay, I understand that. So with that being said, in order for something to be a scientific law, like I'm assuming the Coriolis Effect, are you considering that a law or just a theory?
What do you mean?
Is it something that we observe 100% of the time, or is it something that we just sometimes observe and we have to figure out what's going on there?
Yeah. So again, it's going to be something that we can always observe, right? We can see it with, storm systems, hurricanes, stuff like that.
Okay, perfect.
But,
so I'm glad we agree on that.
Between a law and a scientific theory, though. So a law is just going to be, for example, like gravity. That is a law. Mass attracts mass, regardless of what we say, like why it happens.
What about all the physicists? What about all the people in the field that are actually currently saying that gravity is a theory? It's not a law.
No. It is a law, and the scientific theory explains causation. So that's going to be, gravity happens because, right? It's the warping of space-time caused by mass within it. Now, if you're asking why mass and or mass warps space-time, that is still a question, right? We're basically it's still looking for a force carrier essentially.
Okay, so we kind of drifted away from the first initial thing, which was that it was easy to prove the rotation of the Earth. You're talking about Coriolis Effect, so let's go ahead and jump back onto that. Coriolis Effect, you claim, is something that we observe 100% of the time.
The pendulum. That's going to be the way or the direction in which it precesses. I'm just talking about the fact it precesses at all.
Okay, so what's causing specifically the precession for the pendulum? Is it the displacement between the Earth and the atmosphere, or
And it's be the rotation of the Earth and the fact that when it swings back downwards, it's going to change its angle that it swings back at. I don't know the exact words for it. I
okay?
could get
So
you
here's
wanted to.
the problem with it though, and I think you can kind of see where I'm going with this, and what doesn't make a whole lot of sense if you could help clarify. See, the thing is that the Coriolis effect is something that apparently happens with certain things like hurricanes, with pendulums. Foucault's pendulum, actually, it's really funny when you look into that. You can't find a pendulum that doesn't have a motor in it that has to keep it going.
You can build one. You can make one yourself.
Well, no,
You
it
don't need
doesn't. It doesn't go for continuously enough for you to see anything. You actually have to build one with the motor in it to keep it going.
No, you
That's
don't.
not true.
Yeah, I mean the motor will keep it going, or they'll have a magnet at the end that keeps it swinging back and forth. Doesn't change the direction though. But you can just build a long enough string with a weight at the bottom, and you can get the precession over like 30 minutes, and you'll see that it's absolutely changing.
Okay. Well, here's the thing, and again, here's the problem with everything, is that the claim is from the globe believers that the atmosphere, the reason why we don't experience the motion of the Earth, besides the fact that it's relatively constant, is the fact that the atmosphere is basically moving lockstep with the Earth. And the problem with that is that if that is the case, and we're not able to actually experience the motion in that way, then when you have something like basically I'm getting at that it's an inconsistent law. We have something that Earth is spinning beneath pendulums, it spins beneath bullets, it spins beneath storms, but it doesn't spin the whole atmosphere, it doesn't spin beneath planes, it doesn't spin beneath hot air balloons or anything like that.
So you have to understand when we're talking about a helicopter, if you just hover it directly above, right, without going forward or backward or anything, you're just going to conserve that momentum. You're already on the moving surface. It's not like you go up and you're just separate from it. That momentum is imparted upon you.
What do you mean? Because the pendulum is as much separate as a helicopter is from the Earth.
Yeah, but a helicopter isn't a pendulum. It's not swinging back and forth. We're not going to see it precess.
What about, okay, so, but it's also spinning beneath bullets, it's also spinning beneath storms. You're focusing in on the pendulum, and the claim is that it's spinning beneath all these different things, but it doesn't spin beneath planes, it doesn't spin beneath hot air balloons, and it doesn't spin beneath zeppelins. Everything that detaches itself from the Earth. And also, with the Coriolis effect being a positive claim, basically what should happen is that it should be quicker. I can't remember which way it was off the top of my head, but it should be quicker to go one way than the other, depending on the spin of the Earth, if the Coriolis effect works, in fact, the way that you say it does.
Why would you be going quicker? You still have the momentum imparted upon you from the Earth.
Well, no, you left the Earth's surface. It's very, very simple. It's not complicated at all. When you leave the surface, because if you can see it spin underneath the pendulum and underneath the hurricanes that are also detached from the Earth's surface, then that means that when the plane detaches from the Earth's surface, yes, it has some momentum, but once it leaves, it starts gaining other momentum, and it goes the other way, and the Earth is actually spinning underneath the plane.
Hold on. So what force acts on it then? When it leaves the surface of the Earth, right? The only thing that's going to stop it, literally, is if you're going against the rotation. And then, even then, you still have that momentum imparted upon you. So it's
Well,
going
that's
to be,
exactly.
let's say you're at the equator, right? And you're going east, for example, right, with the spin of the Earth. It's going to be 1,000 miles per hour, like the people like to say, plus however fast the plane is going. That's if you're looking at it outside that reference frame.
Well, no,
Do
you're
you-
just invoking the word reference frame, but I mean, in all sense.
Wait. Globeman, I'm hopping out. It was nice for you to have me, man. I'll see you later.
Oh, yeah, for sure.
Yeah,
Thanks for
Bring Blitz in.
yeah. Blitz is in the box, Tyler.
Okay. Yeah, Blitz is going to have the big words for you.
So, do you understand what causes the Coriolis effect? It's not
Morning
just
or evening, I guess.
Well, that's what I'm getting
how's it going,
clarification
Blitz?
on. I mean, because the
So the Coriolis effect isn't just the rotation of Earth. Like, for instance, I live in Florida. I deal with hurricanes all the time. When a hurricane is affected by the Coriolis effect, it's because it is large enough to span the distance between like two latitudes, let's say. Because if you're at the equator, we'll use the tangential speeds because that's easier, even though it's technically sort of kind of incorrect. If we're spinning 1,000 miles at the equator, if you go north or south of that to another latitude, technically, since it's smaller there, you're spinning slower. And as you cross those lines, that's what causes if you shoot a bullet from the equator north, it's going to drift because it's heading north and hitting an area that's moving slower in the atmosphere. You know what I mean? So if a plane takes off or a bullet takes off, a bullet's a better example because planes under powered flight. If you shoot a bullet exactly across the equator, it's not going to be affected by Coriolis as long as it stays on that equator. Now, Blitz might call BS and make me totally wrong, but that's my understanding of it. You have to cross either north or south and not just stay in a perfect line. That's what Coriolis is. It's not simply the spin.
Yeah,
Yeah.
so the Coriolis effect occurs when you have a velocity relative to your rotating non-inertial frame that is perpendicular to the angular velocity. So thinking of the angular velocity as pointing in the direction that passes through the rotational axis of the Earth, and like firing a bullet, say from west to east, then yes, there would be a Coriolis effect there because you would have two vectors, one which is say up through the axis of the Earth, and the other which would be say west to east, which would be say right if you're looking on a globe. And so you would have a Coriolis effect. However, it would be pointed, doing some finger stuff. It would be pointed downward rather than in the direction that you would expect to see, like rotational effects that you would expect to see for like hurricanes and such.
Gotcha.
Yeah, so this whole notion about the Coriolis effect, like people who talk about it have no idea what it is. So it's not a good argument for a whole lot of people because it's a complicated phenomena that is
I wouldn't
there's not a
consider
lot of
it great
equation for
proof
it.
for the movement of the Earth. For sure, I wouldn't
You
consider it
don't
that.
need it for the movement of the Earth. All you need to do is you can just put a pendulum at the North Pole or at the South Pole, and then you can just watch it rotate. You don't need to think about the Coriolis effect to understand why that works.
Sure. Assuming that you can get yourself to the North or South
Well,
Pole, I definitely get that.
okay, but wait. So every flat earther thinks that you can get to the North Pole.
I wouldn't know about.
Maybe you disagree about the South Pole, but I've
Well, I'm
never heard
also
a flat
talking
earther
about
say
like
that the North
traveling
Pole
expenses and
is
stuff like that, like just absolutely what's feasible for the common man, not just what's,
So okay, so hold on. Let me walk you through this. So on a globe model, do you understand that if you put a pendulum at the North Pole, that the pendulum will swing in a plane and the Earth will rotate beneath it 24 hours or once every 24 hours, and so
Yes.
it'll appear that the pendulum rotates every 24 hours, right?
Yes.
That's easy to understand. You don't need the Coriolis effect for that at all, right?
Well, that's what I thought the Coriolis effect was the effect
That,
of the Earth spinning and how it looks from the
so
reference
so
frame.
so it
It makes
is, but
things appear to drift.
you don't need to use the language of the Coriolis effect to understand it. You can just watch a video of this happening. Like it's very straightforward, right? Like you can figure out the mathematics of it using the Coriolis effect. That is true. Like using Newtonian mechanics in a non-inertial reference frame. But you don't have to, right? If the pendulum is just swinging back and forth and the Earth is literally beneath it, like rotating, then it will appear as if the pendulum is precessing, right?
My
You don't have
question
to worry
also
about.
would be this in regards to the pendulum, since we're getting on that pretty heavy. How do we know for sure that the pendulum is not the thing that's rotating? Because
What do you mean?
all we see is the pendulum precessing, right? Like we see the effect of
Sure.
the Earth spinning beneath it. How do we
Yep.
know that it's actually the Earth spinning beneath it and not just the pendulum spinning?
So, like in the sense of know, as in the ability to know to know anything at all. You can't really, because our eyes could be deceiving us. But you
Okay,
could
so
run this
even the
experiment on
pendulum's
different.
even the
Hold on,
pendulum's a
let me
terrible
finish.
proof.
Let me finish. While we can't know anything in the absolute sense, what we can do is we can run the experiment at different places in the Earth, and check to see whether it's the pendulum that's spinning, or whether it's the Earth like causing the pendulum to spin in different ways at different places on the Earth, or if there is one underlying simpler assumption that the Earth itself is rotating, quote unquote, beneath the pendulums. And a reasonable approach would be to take the model that has the fewest assumptions.
Yeah, I think that's an easy way to pigeonhole things, though. Also, I mean, don't get me wrong. I understand the value of having a model that incorporates as much as you can. But at the end of the day, if you get to picking apart things and you see that certain things don't work with the model, it wouldn't be wise to assume the model as truth. We can still use the model for mathematics and for predictions and things like that, but it doesn't necessarily mean that it's true. Can we agree on that?
Well, what's wrong with it though? Like that's the thing.
I mean, you're doing this. I actually put out a video on this like yesterday. You're doing this thing where you confuse the map with the territory, right? Like it's a famous quote, which is just to say, like, the models that we use in physics are not necessarily reality, but that's all we have. All we have are the models, right? Like that's all we can do. So we treat them as if they are reality.
Okay. So I
Like,
have
so if
with
you
that
run a
in
model,
mind, because you just said that we basically have to, like there's no other choice. And I completely disagree with that. We actually came to, I mean, I'm sure you're familiar with the quote crisis in cosmology and how we came to a crossroads with the Michelson-Morley experiments.
Well, what do you mean?
Are you talking? Wait, the crisis in cosmology is a recent thing, but the Michelson-Morley experiments were conducted like 100 years ago.
No,
Right.
so there's actually, so what I meant by the crisis in cosmology, I'm not talking about the Michikaku. I understand the confusion. That's the thing with dark matter and the way that the movements from the outer edges of the galaxies aren't quite operating the way that we expect. I'm very familiar with that, so I guess I shouldn't use that term. But I'm familiar with the.
I was referring to the Hubble problem, but sure.
Sure. There was another crisis in cosmology. It was a documentary that I can't remember if it was on the History Channel or which channel it was on. It was on one of the educational quote educational channels, but basically it was when Einstein created the theory of relativity. When first, let me start here. Are you familiar with the Michelson-Morley experiments?
I am
Yeah.
familiar with the Michelson-Morley experiment.
Okay, with both of
That's
them, with obviously with the first one that they did and the second one that they did.
I'm only familiar with the one where they'd used interferometry to show that the ether doesn't exist.
Okay, so that was you're referring to
another?
you're referring to the first one where they detected no detected no apparent deviation in the frequency patterns between the light, and then
Yes,
and then
but there's
that
no ether.
right. Well, they always threw that in, but in the actual documentary, the reason why they determined that there was
Wait
no
a minute,
ether.
hold on. I don't care about a documentary. I'm talking about the actual experiment.
Sure, and if you actually go to the quotes from the people who conducted the experiment, they themselves say that they
You
had a
mean
choice.
Michelson and Morley?
Yes, Michelson-Morley is actually two people, but they actually
Yes,
had.
I said Michelson and Morley.
Sorry. Anyway, semantics. But in any case, if you go through their quotes, they actually say that they were very puzzled. They wanted to keep their assumption that the Earth was moving around the sun, but it really challenged their theory of the ether, which they had held for so long to explain the phenomena with light and magnetism. And so what they decided was that they needed a new theory for that. And so they went with basically shucking the ether so that they can continue to believe that the Earth went around the sun. And if you go to actual Einstein, who had written a book on, well, not himself written a book was written about him, about his creation of relativity. And he actually said that in result of the null experiment, this was before they did the second one. The first Michelson-Morley experiment, the second one was Michelson and somebody else, I can't remember the second name. But the second experiment that they did, they actually upped they claimed that they upped sensitivity. They upped the sensitivity of the experiment over 100 times, and they were able to determine 1/6 of the necessary movement. So they actually, which destroys Einstein's relativity, because he says if we acknowledge the null result as a fact, which means we can't have any ether at all.
Okay, so
but they detected 1/6 the motion in the second experiment.
It's not like this experiment was never done again after the early 1900s. Like, this experiment has been done like dozens of times since, with higher and higher sensitivity. So, and we continually see the absence of any ether wind.
So I gave you the actual name of the experiment. You can look it up
What was
if you would
what
like.
was the second name of the guy?
Give me one
What was
second.
the second name? Because you told me Mickelson, and then you didn't tell me
It'll
the
be
other guy.
yeah. Give me 1 second. It'll be pretty easy to pull up. Mickelson Gale. That was the second name.
How do you spell it? Gayle?
Gale. I
Okay.
believe that's the name.
Are you talking about Mickelson Gale Pearson?
I believe so.
Yeah, this is something that I've heard the name of once or twice, but I've never actually looked into it. All right, what was their result?
They detected, supposedly, they detected 1/6 of the necessary aether drag that would have warranted the Earth moving around the sun, but would have been perfect for the aether moving over the stationary Earth.
Wait a minute, hold on. What I'm looking at right now suggests that it contradicts the hypothesis of complete ether drag. Yeah. So everything that I'm looking at now, and again, I'm just looking at some cursory stuff, like some summaries and stuff. But it does not say that they detected significant ether drag.
Well, I'm not talking about significant ether drag. Significant ether drag would have been the 6 parts that they needed. They only discovered 1/6. But the fact that it wasn't 0 is all that we need to
Hold on, can you
debunk
link
the
me a source to
relativity.
this? Can you link me a source to this? Or send me a source, because I mean you gave me everything that I'm looking with regards to this experiment does not say anything about 1/6 anything, like 1/6 of the intended effect.
Well, you're gonna have to go into the actual. I'll see if I can find it, but you're gonna have to go into the actual data of it. And as you guys know, Google's not very friendly to this kind of shit. But I mean, you guys obviously are very scientific. You should be able to dig into the metadata pretty easy and see exactly what's going on
It's
there.
not a matter of metadata. It's a matter of actually reading the paper.
Well, that's what I meant. Like I said, semantics.
But like, it's not semantics again. But regardless, like this experiment, like okay, so this Mickelson Gale Pearson experiment was conducted in 1925, right? What it wasn't, but the original Mickelson Morley experiment wasn't like the end all be all. It wasn't like Mickelson Morley. Okay, well, it looks like there's no ether, and then Mickelson Gale Pearson, it looks like that there might be some ether. Like this has been continually measured upwards as recently as like 10 years ago.
So
right.
I mean, obviously, even in the searches that you find forthright, I mean, there's a difference in the wording. The Michelson Morley says null result. The Michelson Gale says they didn't detect significant ether drag. I mean, it's right there in front of your face.
Yeah, I think I can, maybe Blitz will understand what they're saying here. So it says, a first step to explaining the Michelson and Morley experiments null result was found in the Fitzgerald-Lawrence contradiction hypothesis, now simply called length prediction, or I can't even speak, contraction
Length
or
contraction. You have to
first
actually
proposed
believe
by,
that the length of the contraction, or sorry, the length of the arm contracted with physical space.
Yeah, but it came out
this
at
is
the very end.
consistent with the time dilation that we see for GPS satellites. But okay.
Yeah,
and then at
much
the
more
end of,
believable than the Earth's just not moving.
right, and it said, but since there was no reason at the time to assume that the binding forces in matter are of electric origin, length contraction of matter in motion with no respect to the ether was considered an ad hoc hypothesis.
We now know better, right? We now know that the molecular and atomic forces that hold stuff together is electrical in nature, electrical and magnetic for that matter. So it's not. It is no longer considered ad hoc because it is consistent with the special theory of relativity, which also explains electromagnetism, or unifies with electromagnetism, rather.
Someone said, "Can we clarify what ether is?" It was the supposed medium for light to.
Hold on. What
professors
do that?
Give me 1 second here. Let me pull it up.
Because I know what they're talking about. Like as you rise in elevation, there's like more static charge or something like that. I've heard that, but then wouldn't we expect? Man, I forgot what it was.
It's incoherent dielectric acceleration. It's incoherent because it just hasn't polarized, and it won't polarize because of the difference in charges between the sky and the Earth. What is a muon? And how does that
Okay,
prove
so
time dilation?
a muon, M-U-O-N, is it's a subatomic particle, which is very much like an electron, but well, not slightly, but significantly heavier. It's also unstable. We can produce them in a lab, and when they're slow, they decay relatively quickly. However, given the thickness of our atmosphere, one would expect that if there were muons coming from cosmic sources, i.e. coming from outside of the Earth and coming through our atmosphere, if there were no time dilation and if there were no length contraction, they would not survive long enough to make it through the atmosphere. They would decay before they made it to our detectors. However, we do detect them, which suggests that something must be happening that allows them to survive that process. Now, that something is that they experience, or from our perspective, they experience time slower. From their perspective, the distance to the ground is shorter. These are both predictions made by special relativity, which this observation of muons confirms.
So
There was another one, a little bit more simple too. Literally, they took a. This was a while ago. I'm sure it's something that's been repeated more now, but that's going to be in like the ISS and stuff. So I don't want to have to invoke them. But it was literally they took like an atomic clock on a plane, and they flew it around the world. Like I think they were up in the air for like I don't know 24 hours, maybe a little longer, and they actually saw that on that clock it was reading that they had what was it experienced? I think it was less time, or it was either less or more time while on that plane. Can't remember exactly which one it was, but it was one that I posted the other day. Well, not the other
It
day.
should, in
Me,
principle, experience less time.
I
I'm
can
not
figure out
familiar with that particular
the
demonstration, but yeah, it should experience less time.
yeah, the Hafele and Keating experiment. I don't know how to say the first name.
The Hafele, how do you spell it?
Hafele, then hyphen Keating, Keating.
Let's see. I have not seen this, but it sounds reasonable. Okay, so yeah, they just flew some atomic clocks aboard commercial airlines. Okay.
Yep. Yeah, and they were able to
Tyler,
prove.
But that's not something that you could, in
sorry,
principle, do at
I'm
home.
gonna jump out. John in the box said he had a couple of questions for Blitz, and I'm just sitting here listening. So I'll jump out and let him in.
Okay, sounds good. Thanks for coming in.
Cool. Yeah. Take care, guys.
Yep, have a good one. Yeah, I was trying to remember the name. It had been a while since I posted that. That was in April.
Just so I know who's talking, Blitz, who's the flat earther and the just regular?
I believe Troubling is the flat earther.
Yes,
Oh,
sir.
okay.
Globe skeptic.
All right. I'll
Or
let you guys
Globe
continue.
Skeptic.
I got a couple questions in a couple minutes though.
But yeah, so Troubling. So this whole business of like time dilation and or length contraction, which are just two sides of the same coin. Like there are multiple different experiments that can confirm this. The muon one is one that can be explicitly done at home.
What is a muon again?
It's a subatomic particle.
And where does it come
It's
from?
basically an electron, but significantly more massive.
Okay, and it comes from where?
Well, it comes from a whole bunch of different sources. We can produce them in particle accelerators. We do that all the time. But also, it seems to be the case that they rain down from the sky occasionally.
Okay, so do you know where they start to come in at?
Do you mean like where they start from, like
yeah,
in
like
space, or do you mean?
So if they come from all these different sources and stuff, I mean, I'm just trying to determine how you know for sure that they are coming, that they got to come all the way through the atmosphere, and even if they did, how that proves time dilation.
Well, okay. So what you can do is you can look at what direction they were moving in when you detect them, right? And so you can extrapolate what direction they came from.
I mean, let's just be honest. If we're talking about subatomic particles, I mean, you can't detect those. How do you detect those from home?
Yes, you can. You can build a cloud chamber in your garage for like $50.
I thought subatomic particles were invisible to the human eye.
They are, but they ionize. They can ionize supersaturated alcohol vapors it's called a cloud chamber, and they will produce little streaks that you can see in your cloud chamber because they ionize or because they produce what's it called? I'm not an experimentalist, so you'll have to forgive me on this. It'll produce it's like a little point of condensation where because they ionized an atom or a molecule in the gas, and the condensation will follow the track or the path that the particle takes, and you can see that path.
So wait a second.
It's like macroscopic. You can Google pictures of this. It's a thing. Like I built one before. It's not so hard.
No, I'm trying to make sense of it, because honestly, I mean, I'm just gonna be completely honest with you. It might just be me. I might be retarded, but it sounds really, really stupid, because it sounds like you just said that the path of the water, the path downward that the water takes, the condensation takes, proves that the existence of the subatomic particle, and I just really don't get that.
Well, so you see streaks in so what you'll see basically is it's like a chamber filled with like kind of a foggy gas, and you will see streaks appearing in that are going random directions, right? And some of them will be really short streaks, some of them will be somewhat longer streaks. The question is what are causing those streaks?
And
so what you can do, go ahead.
This was for the smoke chamber. This is alcohol and what?
Usually alcohol vapor, yeah.
Okay, so have you ever cleaned alcohol vapor and just pure alcohol vapor, or what percentage is it?
Sorry?
What kind of alcohol are you using?
You just need super saturated alcohol. I don't remember what the exact percentage was. I did the experiment as an undergrad.
Like isopropyl or?
So you're on the same page.
I think it was just ethanol.
Okay, so food
this is the first one. So you can see he has this, and then you can see the little streak go through it. And more. It almost looks like entirely random. It's not, just like it's, like a little droplet on the glass or something.
Okay, my other question would be if this is something that is easy enough for me to create in my garage with just a few simple tools, that, I mean, how are we so certain that this is only coming from the sky and that these things aren't everywhere?
Yeah. So I was getting to that. Right. So the next thing that you can do, so the way to build just a simple cloud chamber is not so hard. You basically need some dry ice. I just Googled it. Apparently the alcohol that you use is isopropanol. Basically some dry ice, some isopropanol. You'll need an acrylic chamber just so you can contain it all. Whatever, not so hard to build. You'll have a super saturated alcohol vapor in your chamber, and then you'll just start seeing streaks like Globeman just showed. Now those streaks are going to be in random directions, but what you can do is you can start asking questions. You can, for example, either build or get a strong magnet and put it next to your cloud chamber, and you'll start to see that some of these streaks will curl in various directions. Not all of them, but some of them will. And so that would suggest that those streaks are made by charged particles, because if they're only curling in under the influence of a magnetic field, that means they have to be charged. So right away that tells us that whatever is causing the streak is a charged phenomenon, and it's a charged phenomenon that's traveling through the gas, creating these streaks. Then you have to ask questions about okay, well, where did it come from? So what you can do is you can put your magnet only, say, on the bottom half, and then you can ask, okay, well, first, before it gets to the magnet part of your chamber, you'll see the streaks being straight, and then they'll encounter the magnetic field part, and then they'll curve, and then you can trace back the path of the particles in the straight part to figure out where they came from. And if they were coming from the sky, or if they were coming from above you, then that means that either they're coming from some cosmological source or they're coming from our atmosphere. And then you just have to ask, okay, well, what could be causing these things to exist? And you just keep unraveling what the causes are, adjusting your experiment here or there, and you'll eventually come to the conclusion that these things, you can, based off of the radius at which they curve under the influence of the magnetic field, you can figure out how massive they are. You can figure out what their charge is. You can figure out basically, you can figure out a lot about them, and then you can come to the conclusion that they are muons. Muons are the only thing that are negatively charged with the mass of 90. It's something like 180 times the mass of an electron, and then you can go and you can figure out what the either figure it out or Google it, the decay rate of muons. They do decay, and then you come to the conclusion that, well, they came from the sky. They are traveling with such and such a speed, which you can figure out basically by how far they travel, and they could not have gotten from They cannot have originated from outside of our atmosphere and made it to us in the amount of time that they would need to decay.
Yeah, so there's like, I mean, I'll be honest with you. I mean, I kind of was waiting for a polite point to interject, but it kind of seems like you can just go on and on and on about it. No disrespect or anything. I just know it's an extensive topic. But I just like to say a couple things. For one, I had a feeling it was isopropyl alcohol because of the coloring, and the fact that with the dry ice. I mean, dry ice is part water, is it not? Correct me if I'm wrong on that.
No, it's not. It's CO2.
It's complete CO2. Okay, CO2.
Yeah.
Okay, so in any case, I know that when isopropyl alcohol interacts with certain things, it does make a cloudy color. And I'm not saying like it's an exact thing like that, but I'm just saying that.
Well, no. The cloud is there so that you can see the streaks in it. That's the point of the cloud.
Okay. Well, I mean, still, the only thing that you're showing is that there's something honestly, you're only showing that there's something magnetized. You're not. You're not really able.
Something with electric charge.
Exactly. Is there not an electric force between all molecules?
Yes, but there aren't ones that are traveling at near the speed of light.
Okay, now you lost me again. So we're seeing these little streaks. I mean, we're not seeing these streaks at the speed of light. What does that have to do with anything?
No, but you can figure. Well, I mean, like if you got a camera and you looked at how quickly they appeared, you would see that they appeared instantaneously rather than something moving through them slowly, which suggests that it's faster than any camera that you could buy.
Well, I mean, the force of magnetism, correct me if I'm wrong, but that's an instantaneous force, is it not?
No, it's not. No.
I mean, it's just on or off, like a light.
No. The electromagnetic forces are transmitted at the speed of light.
That's what I just said. Instantaneous. Like
that's not instantaneous. It's very fast, not instantaneous.
Yeah. I mean, essentially, for me and you purposes, it's instantaneous. I mean, we're not going to measure a significant difference.
Yeah, but this is a particle moving at this speed, not like some force being communicated.
Okay, but my point is that we're seeing the lines once we put the magnet to it. Is that correct? Or
no, the lines were there beforehand. And then you put a magnet there, and you see the lines start to curve.
Okay, so I mean, how do we know that the lines are just a result of the CO2 and the alcohol coming together, making that cloudy substance?
Hold on. I have to disconnect and reconnect because I actually just hit the home button. I'm gonna do it really quick.
Okay, I'll let you back.
All right,
I appreciate that guy's patience.
Yeah. Blitz is super nice, super knowledgeable.
I'm sorry. I just hit the home button and it closed out of TikTok. So when I reopened it, I was getting an echo. Can you repeat what you were saying, Troubling?
I'm sorry. Were you talking to me?
Yeah. Can you repeat what you were saying? Because I missed that because I had to disconnect and reconnect, and there was like echoes and stuff. So.
Oh, sure thing. I was just trying to get to how the lines being moved by a magnet proves that there's a subatomic particle that is moving at the speed of light through the atmosphere.
Well, it proves that there is a particle. It proves that it's a magnetically charged or an electrically charged particle moving.
I'll give you that, and that a particle is just a point of inertia. So I definitely will give you that. But I mean, how do we know that that's a particle moving at the speed of light through the atmosphere? Because of an experiment that we did in our garage.
Like how quickly does the track appear? Right. You can like, for example, if the particle is moving at 1 meter per second, then the track would appear, it would grow in length at 1 meter per second, right?
I'm sorry, can you repeat that one more time?
So let's suppose that they're not traveling at near the speed of light, right? Let's say let's just for the sake of argument, let's assume that they're traveling at say 1 meter per second, whatever these charged particles are. If they were traveling at 1 meter per second, that means that you would expect to see the length of these tracks grow at 1 meter per second. So they would start off with 0 length, and then they would get longer slowly at exactly 1 meter per second, because that's the rate at which the thing is traveling through the alcohol vapor, right?
Right, I get that.
So all you have to do is figure out how quickly do the tracks grow, and that will tell you how fast the thing was moving, right?
But we're watching something happen instantaneously. So I get what you're putting down.
It happens faster than any camera that we can get. You could get like a super high-speed camera, and it would still appear probably. Well, I don't know how good our cameras are nowadays, but it would appear like even with our best cameras, it would appear remarkably fast, like one or maybe 2 frames. So that will give you a lower bound on the speed that the thing is moving at. Then you can ask questions about, like, for example, well, if it's moving that fast and it's still bending this much under the influence of the magnetic field, what is its mass? You can ask that question, and then you'd come up with an answer for what its mass has to be.
Well, I have a great
This is a
question for the
Yep.
particles that are coming from space that are affected by magnetism. How are they getting through our magnetic field?
They're moving very, very quickly, and our magnetic field is very, very weak.
But even once they get to us, I mean, we're moving it with a magnet in real time. So I'm
Yeah,
just
the magnets that we use, like neodymium magnets, are significantly stronger than the magnetic field of Earth.
all
Like
right.
orders of magnitude stronger.
All right. My 2 questions are kind of off topic, but they're quick. If I could just throw them in now. Blitz, and troubling. Would you guys agree that, like, no matter what, no human actually knows what's going on? Like, we're either basing it off of science or we're basing it off of our own belief. But
Well, hold
either
on.
way, we don't even know if the science is real. Like, it's all based on, like, the information that's been put on us since we were born.
Well, no, because that's the thing, right? Because what you're implying is indoctrination, right? Not thinking critically about it, just accepting it. Science is quite literally the opposite of that. Like you're putting everything
I
to the
would
test.
I would like to interject on that. I mean, I know the idea of science is to do that, but I mean, if we're talking about what mainstream science does, I mean, you don't have to look very hard. I mean, Michio Kaku said himself in the field of cosmology, we don't do the scientific method. We fly by the seat of our pants. We make equations. We do guesswork. And that's
Yeah, that
not the
was
scientific method.
yeah, that was theoretical physics.
I mean, that's kind of what we're talking about.
No, we're not.
We're talking about
I just gave
subatomic
you an example of an
particles.
experiment.
No, we're talking
I
about
just gave you an
subatomic
example of an
particles.
experiment. I
Okay,
just gave you an example of an experiment. It's experimental.
and then just for troubling, on the flat Earth, do you believe that there's more evidence to support flat Earth or more evidence to support round Earth?
I believe
In
there's
your
much, in my opinion, I believe there's much more terrestrial evidence to support a flat plane. But I know that there's obviously been a big debate, so it's been going both ways. That's why when I come into things like this, I'm not going to be one of those types of people that just tries to hammer and shuts people down, shuts people up. I let them talk, say their thing. And I do understand that I don't understand everything. As far as your first question, I do fully admit that everything that we believe or think that we know is a belief. We do rely on the scientific method for a lot of things, but the scientific method is not the 100% best way to determine all things true. For example, you can't use the scientific method to prove that yesterday happened, but you and I would definitely not disagree that yesterday happened. So
So just
and
to
then
interject, I mean,
off of that, this is just gonna be my last thing, and I'm gonna leave y'all. So then off of that to Blitz, on the scientific method argument, I'm not as educated as you guys, so I probably sound dumb compared to you, but would scientific method. So the scientific method, if we're basing it all on science, back to 1,000 years ago, beginning of time, it's all based on basically the person that came up with this is the best explanation for this, but nothing is
are you talking?
100%. Would
So
you believe
so
that, Blitz, or are you like
so
what's your opinion?
there's a certain degree to which nobody can know anything. No one here can prove that they're not just a brain in a vat being fed data, right? Like we can't prove that. But if we're all agreeing that we should believe what our senses and what our memory tell us, then we can't given that assumption, then we can function using the scientific method. It's not just like, is it like can we really know anything at all? Now, to answer your question directly, the whole business of the best theory or whatever, like again, this is confusing the map for the territory, like I said earlier. We have models, and the best we can do is assume those models we have models that make predictions and are useful for predicting how the universe behaves. The best we can do is assume our universe will behave consistently with those models until we know otherwise, basically. We can't know anything about what the universe actually is. Like, the universe is not a mathematical object, unless you believe in the mathematical universe, which I don't. But it's describable by mathematics. So like yes, it is just like the best model, but that's all we have access to.
Mm-hmm. And then so basically if we're just looking at what we have, then the flat earthers are basically throwing out the best evidence that we have and going with their own theory and dismissing what we do have.
Actually, no. The reason why the flat earther community exists is because we don't take the mathematical breadcrumbs as the end all be all evidence. The first thing that leads people to flat earth is the fact that we see too far. Now, there's a justification for that. The justification is superlumin refraction that apparently allows you to see things perfectly placed on the horizon that are supposed to be well beyond the horizon. And we've seen this effect bring a horizon that's supposed to be a mile away up to 11 miles into view. But with that being said, we really don't know for 100% as far as like the R value, the radius of Earth being determined by Eratosthenes or anything. That is, honestly, that's just horse shit. You can take two sticks, put it on your table, put a flashlight above one of the sticks, and then you can extrapolate from an infinite light source the circumference of your perfectly flat table. So the sticks and shadows experiment definitely isn't good proof.
Well, I mean, with two observers, maybe, but once you have 3, 4, 5, it falls apart for a local sun.
No, it doesn't. If you can literally do the same experiment.
No, it's literally once you have three sticks, or I prefer to talk about wells, but once you have 3 sticks or 3 wells, it is precisely not like you can just write down a model and you can figure out how long the shadow should be, and if you have a local sun for a flat Earth, the data just doesn't line up. Like, it just doesn't agree.
And you guys have actually
prove the existence of it.
Because we've actually done the local sun experiment over the table. I mean, have you guys actually done that, measured it, did the mathematics, and can say that confidently?
Yeah, with 3 for sure. That's not hard. You can even just do it on paper and figure it out. You can
you're just saying that because the mathematics works, we can just do it on paper. That doesn't work for flat earthers, and that's why you guys don't convince flat earthers. Flat earthers actually get their table, put 3 dominoes on the table, put a flashlight up, and actually take the measurement of the shadows, and then try to work it out. See, there's a huge difference between the way that we're doing science.
You can't just use a flashlight. You have to use the sun, right? Because if you're using a flashlight, that implies, or like you're making the built-in assumption that you have a local sun, right? You have to use the sun. You can't just use a flashlight.
No, we see divergent rays from the sun. We're just assuming that it's infinite. That's literally what Eratosthenes did. He assumed an infinite sun.
Well, he assumed that it was infinitely far away. I mean,
right.
Yes.
So that's what we'll do with that's literally what we'll do with the flashlight. You hold it above the table. You hold it directly over one, and you work out the math.
But no. But you're missing the point. If you have an infinitely far away sun or a very, very far away sun, then the rays are parallel, and you will not have that for a flashlight.
Yeah, the problem is that we never see parallel rays.
Yes, you do.
No, we don't. We see corpuscular rays. We have a name for it. Corpuscular rays. No, they're not. They're definitely not.
Yes, they are. They're just as parallel as train tracks are.
It's just seeming to converge in the distance, but they're not actually converging. No, that's something, because I know people try to say, like, oh, just use corpuscular rays.
See, there you guys go. See, that's the thing about the science that you guys do and the science that flat earthers do. We take the evidence at face value while you guys continue to move the goalpost. No, you guys just move the goalpost. You say, well, no, it just seems to come together. No, we see it come together. They're corpuscular rays. They're not parallel.
Are you telling me that
rays from above?
Are you telling me that the train tracks that appear to converge actually do converge if you're looking at them as they go up into the distance?
Wow, all right, that was good.
That is a good one. But you haven't verified that it's an infinite distance. That's the thing. It could be close. It could be far. You don't know.
No, you're right. All I've verified is that it's not a close sun on a flat Earth. That's all you need. That's all the that's all you need, and that's
No,
all
you didn't.
like
You
you can
didn't.
get that
You
just
did
from
not
the
verify that it's
Aristotelian
a.
experiment.
You did not verify that it's a infinitely
No,
far
no,
sun over.
I didn't have to verify that. I'm not trying to verify that. I'm just trying to disprove that the sun is close and that the Earth is flat. If you assume that the sun is close and the Earth is flat, the experimental evidence does not line up with what you would predict.
Yeah, I disagree
All right.
completely.
Okay, so what does the experimental what does the model predict, and what does the experiment show?
Well, I mean, if you've done the experiment, I'm all ears.
I can tell you, the experiment will show a trigonometric relationship between the distance of the sticks and the length of the shadows. The
But that's simply
flat
because of
Earth
the.
model,
That's simply because
the
of the
flat
relation
Earth
of the
model
sun
with
to
a
the
local sun.
objects.
No, hold on. The flat Earth model with a local sun predicts a linear relationship between the length of the shadows and the distance of the sticks, not trigonometric. The fact that those two things don't agree is concrete evidence that the flat Earth local sun model cannot be correct.
So explain the difference between trigonometrical effect and linear effect. Actually, I know what linear effect means. What do you mean specifically by trigonometrical effect?
I'd have to work out the details again, but it's either
That's
it's
what
either
I'd
that
like for you to do, because I'm saying that you're
sorry.
saying that it reacts to
No,
a way
I
that's.
worked this out like last week. It's either the length of the shadow either goes as the tangent of the height of the sun, or of the distance divided by the height that the sun is above it, or the inverse or the cotangent. I don't remember which one it was, but I could work that out in a few minutes if you needed me to.
Sure. I mean, that's what we're here to do.
All right, let me get out a pen and paper.
All
And then
right. My
we can
last
actually
little
see
thing.
cellular rays above. That was what I mentioned. They are parallel. Just if you're standing in between them, same thing as train tracks seem to converge to a point. Like this is actually
I mean,
easy
I
to do.
took an art class. I know that things that are parallel can seem to converge, but I'm just saying if you don't actually ever see them converge, you haven't verified that it's parallel or that it's actually converging. We're just assuming. I mean, we can at
Right.
least
Well,
agree on that.
with the corpuscular rays, if we look at them from above, we do see that they are in fact parallel.
That's funny because when we look at it from above, we also see a local hotspot, like an extremely local hotspot, and that would be impossible with an extremely distant sun. But don't mind me. I'd love to see this mathematics.
Hold on, I'm work. One second. Let me turn on my camera and reverse it.
By a
All right,
And
hot
then,
drawing a picture.
I'd also
gonna-
like to know why we could see the moon that was over Australia while we had a rocket that was over Nevada. I'd love to see the math for that.
they're not on opposite sides of the Earth.
All right, so we have two triangles here. We have one triangle. So these angles are the same. I need to also get a width of the. I use the well experiment. You'll have to forgive me. I don't like using sticks. I like using wells because it's easier to draw. Let's say that each well is, say, has a width of, say, s. So what we have is that the height h. Actually, we don't even need this angle. We can just use relative triangles. So we have h divided by capital H. These are similar triangles because they have the same angle, and they're connected by a parallel line. This is some basic geometry stuff. We have an h here, we have a capital H here. These two triangles are similar. So we have h divided by h is equal to s, that's this distance here, divided by d. So this tells us that h should be equal to capital H times s over d. Sorry, it wasn't a linear relationship. It was inverse with distance. So as the distance gets big, the value h gets small. But the point is this is the relationship that you'd expect from a flat Earth. Flat Earth, close sun. You would expect that the distance that you can see in a well, where the sun is directly over another well, some distance d away, goes as the inverse of the distance that you are away from that well. This is not what we observe. We observe instead the distance goes as something like 1 over the tangent of the distance, divided by the radius of the Earth or something like that. But you don't even need to know you don't even need to know a model that does predict what we observe in order to discount the fact that the flat Earth, this model, the model that you guys use, does not agree with the evidence.
Yeah, I would like to actually see that in play in real time because I mean I
Okay,
get
so
mathematics, but
so
I get.
I did the math for you. Now you go do the experiment.
I mean, sure. I mean, I can definitely do that. Not right this second,
I'm
but
not the one that has to be convinced, right? And if I showed you a video of this, you wouldn't believe me.
well, I mean, honestly, if you showed me a video of it, I'd be more apt to believe you because you're actually showing me real world evidence. The only thing I ever get from Globers is just
No, no,
mathematics, and that's why
I
people
could
don't
show you a
believe you.
video of a whole bunch of things that you wouldn't believe. I could show you video. So the only way that you're going to be convinced is to go and actually do the experiment yourself and measure how the height varies with distance.
This is a great
So like
intro.
that's the only way that you will be convinced. If I show you a video, you'll say it's edited, or you'll say that like there's some external like honestly, I've had this conversation with a dozen flat earthers before. They all say, "Oh well, the live video that you're showing me, that's edited. Oh, the pictures that you showed me, those are Photoshop." Like it's me showing you evidence doesn't do anything for you, so you have to do it yourself.
I
Like
can
this is
definitely get
what
behind
should
that.
happen.
That's no problem. I can definitely agree with
This is
that.
what should happen. If this does not happen, if this is not the result that you obtain with your experiment, then your model is wrong.
Oh, well, hold on. No, I think that the first thing that we should do is verify that that equation is real. So the first thing that we do is you take the sticks and shadows on a flat surface, a known flat surface, and then you verify that the equation is real. That way we know it represents reality. And then
Yeah,
we do
okay,
the
you can get a light
experiment
bulb and you can do
terrestrial.
that. You can get a light bulb and do that. That's fine.
Absolutely. So flat, like
A flashlight probably wouldn't work, by the way, because a flashlight is more or less directed, while our sun, presumably, the model that we're using, is probably closer to a light bulb. So I would use a light bulb, but a flashlight, you just might get results that aren't so great.
right now, try to get it
Like
to
it'd be hard
scale
to.
for sure. But you get the idea that I was going behind. You know,
Yes.
it's not complicated. It's very
No,
straightforward. I'm just
it's really
trying to
not.
bring it. I'm actually trying to use this channel to bridge across the aisle because I know that there's a lot of flat earthers that don't listen to anything that Globers have to say, and then the same thing across the other aisle. The Globe earthers don't listen to any evidences that the flat earthers say, and then there's no convincing one way or the other, and that's why debates like this keep happening. So. If things can be actually worked out in a way that everybody can do the experiment hands on, and then there's no relying on authority, that's real science, duplicatable,
So
then
there is going to be one problem with this, right? You're going to have to be able to go. So it depends on how far away you think the sun is. But if you think the sun is quite far away, like 30,000 miles or something like that, because I've heard some flat earthers think that, you will have to go a substantial distance away to see this effect, right? So you'll have to, be somewhat careful.
yeah, it's gonna be.
And
I'm
you might,
not. It's not. It's gonna be a little tricky to scale.
yeah, certainly. I mean, like this equation doesn't care about scale, right? But like, contact a friend on the other side of the country or something, and have them do the same experiment at the same time.
All right, last question for troubling, but you seem pretty open. Like other than flat earthers, like you said. So, so would you, for the only way for you to believe that the Earth isn't flat, like, would you have to like go into space rocket and be above the Earth like yourself?
So
Or
I'll be
I
completely
said,
honest with you on that. I would personally I wouldn't get into a rocket just because regardless of what model you believe in, going into a rocket's pretty freaking dangerous. So I don't do roller coasters even that well, so it's not really something for me. I don't think it takes quite that much to convince me, but there is definitely a lot of things that would need to happen. Like more of things like today would definitely help, where we're just going over the basic stuff. We're going over the math. Open to explanation, open to criticism. Then that's the perfect way to go about it. Obviously, nothing happens overnight for anybody, but at the same time, you could ask. A lot of times I have asked that same question to Globe Earth believers. What would it take to convince you? Because I've when the chance where I'm kind of taking more of a student seat in this live, but I have taken the seat where I'm more oppositive. And, the facts are that we do see too far, that NASA has been caught with their pants around their legs fabricating stuff, and that's pretty easy to prove. And so when you take all that into consideration, you then start asking questions like, why are they faking stuff like that? And there's a divergent on the conspiracy community. Half of them thinks that there's a big alien conspiracy that they're covering up, so that's why they give us all kinds of fake space stuff. And the other side says that the whole space is just completely fake, and that the extraterrestrials are coming from outer lands over the ice wall. But in any case, with the claims like that, we really don't have proof one way or the other. There are stories, on both sides. We got stories of people going to space, and all that kinds of stuff. And we got stories of people going across the ice wall and discovering different lands and different people. So it's,
Do we have photos from that?
I'm guessing you heard of Admiral Byrd troubling.
Yeah, I'm familiar with Admiral Byrd. There's also a book called The Iron Republic. That's a pretty interesting read.
But I was going to say that I tried
on
to
the
take people out of the thing, right? Like, I would disagree. I don't think NASA has fake things. I think they've been transparent, but that's neither here nor there because we don't even need them to prove the shape of the Earth. We don't need to go to space to figure that out. Like, it's really easy to do from the surface.
Well, the thing that I found interesting was just how when things did come up that that the flat earthers were saying, the globe earthers did seem to move the globe post. One of the first things that was obvious.
Globe post that was moved.
I mean, the superlumin refraction was a globe post that was moved. We didn't even hear about that. That was something that didn't even come up until people started taking the long distance photography and saying, "Hey, we can see way too far than the geometric horizon's supposed to allow." And
well, I mean, that's because they try to use 8 inches per mile squared, which is wrong. I mean, that's a parabolic approximation. It's
well, see, that
decent
tells me that already tells me that you haven't done the full research on it, because although it is a parabolic approximation, if you actually put it side by side to the Earth curvature calculator, it's good all the way up to about 1,000 miles.
And that's why I was saying that's if you have your eyeball directly on the surface, but that does not account for observer height or hidden height of an object. That's the completely wrong formula to figure that out.
No, we were using the Earth curvature calculators, and that we were using those directly, and they did account for
Why do you
observer
trust
height.
those calculators?
Right. Because that shows drop from a tangent. But yeah, answer Blitzphd first.
Why do you
because
trust those calculators?
Well, because we don't trust them, but the idea was that we're trying to debunk them. So if they didn't agree with what the observations were, then the calculator is debunked.
Debunk the calculator. You haven't debunked the model.
Well, the fact that we saw way too far and then had to bring in superlumin refraction to account for it.
According to what? According to what? According to these calculators?
Okay, so do you guys not agree with any of the Earth curvature calculators?
No,
I don't
do.
I don't use an Earth curvature calculator. I just do the math.
And I would say I do, but I use the ones that are going to show you a model, and they give you the actual, observer height, hidden height, and stuff. They're not giving you just based off of a tangent, because that's what those Earth curvature calculators.
Right. I was using the. I was actually using the. It starts with a W.
Walter Bisland.
Yeah.
Yeah. I mean, I have yet to see anything that doesn't match the model with that.
Well, I mean, hold on. The reason why is because the globe post just got moved so that it could match. They assumed superlumin refraction so to account for it, and they said because there was some slight distortion in the oil rigs in the Black Swan experiment that I'm sure you're familiar with. I mean, you should be familiar that we had an observer height of just 1 foot. I mean, that was calculated. It's put right into the calculator. And without that superlumin refraction, I mean, you can't possibly see that far. We're only supposed to be able to see like 2 miles off into the distance, and then with regular refraction, with the regular refractive index that we're supposedly normally seeing, it only allows you to see just a little bit further, so it would have been about 3.5 miles from that. But with the superlumin refraction, which is something that we can never ever see except for when we're doing these long distance observations that debunk the globe, that's when we can see superlumin refraction where it really didn't even have a number put to it to check. All they did was slide the scale until it fit the right spot. And that's not really science. That's just.
Well, I mean, there are coefficients that you can plug in for, light, moderate, strong, and very strong refraction. But that refraction is a real thing. We can't just assume no refraction.
No, I wasn't even assuming no refraction. I was assuming regular refraction. Superlumin refraction. This is what I'm trying to say. Superlumin refraction did not come about until the flat earthers prove
the
that
difference between
the
superlooming and regular looming refraction?
regular looming refraction is not sure the exact equation, but it's some 7 over the r over the radius. You're gonna have to look at the actual equation.
No, like tell me, use, explain it. I don't just want an equation. I want like, what's the difference between these things, like, as ideas, as physical phenomena?
Sure. So refraction is refraction is the way
I know
that
what refraction is. I'm asking about looming and superlooming.
right. So looming refraction is going to be when the light is bending up over the curvature of the Earth, where you could see just a little bit beyond the horizon. The difference between that and superlooming horizon is that superlooming horizon allows you to see much further beyond the horizon.
So it's just so there is no difference. It's just a matter of, like, distance.
Magnitude. Yeah.
So when does looming? So are you okay with looming refraction?
I mean, yeah, I'm okay with the idea that the horizon isn't geometric. The idea that the horizon was geometric was originally a globe claim. Flat earthers debunked that, and then globe earthers had to double back and say, "Well, we never claimed it was geometric."
If you have the surface of if you have a let's move away from the idea of, like, a globular Earth. Let's just say you have air, or let's just say you have, like, some other thing. Mental experiment, right? Would or would there not be refraction as a result of air density being different at different places on the surface?
100%. Regardless of what model that you're working with, there's going to be refraction of the horizon.
So you don't. So what's your problem with superlumin refraction, then?
My problem is that there's absolutely no proof for the actual R value, the actual geometric horizon, the thing that was supposed to block ships in the distance. The original claim was that we know that the Earth is round because watch a ship disappear bottom up in the distance. But the thing is,
that wasn't the first way that we found out that the Earth was round.
yeah, well, that was the first way. It was literally the first claim. They say the first thing that led us to it is the Greeks started sailing around. I can't remember who exactly said it. I know that Bill Nye has said it. Neil deGrasse has said it. If you just go to the mainstream scientists, that's one of the talking points.
They didn't decide that the Earth was round. We've known that the Earth was round for thousands of years, right?
And they say that the first way that led us to leading that way was because we watched ships disappear bottom first.
That was one of the ways, but that's not, like, the only way. Like, that's something that indicates, yeah, that's weird. Like, why is that disappearing? There's something
they say
going on.
that was the reason why we didn't. They say that the reason why we ever believed in a flat Earth is because we didn't really have the ability to sail around and stuff. And once we did, then people started getting smart enough to say, "Oh, hey, we might live on a ball. Look at the way things are disappearing in the distance." And then they started looking at all this other stuff and putting it together over thousands of years, which is why you guys also have perfect mathematics and why the flat Earth has to put their mathematics together. But, George Ellis, who's actually a prominent member in the Globe Society, prominent scientist, cosmologist, he actually said that, he didn't say it was flat, but he did say that he could construct a geocentric Earth, a geocentric universe, and you could not disprove it based on the observations. He said that back in, like, 1993, 94.
Yeah, I mean, I would have to see that because, geocentric, that also is a spherical Earth, which is kind of fun. But
well,
yeah,
all I'm saying is that he said that he could construct it with us at the center, and you can't disprove it. And then Kepler went and said that we have to avoid it at all costs.
Troubling. There's a notion called relative motion, right? In one sense, or you can pick any reference frame that you want, and it is correct. Meaning that, in one sense, the Earth isn't moving and everything is moving around it. From another reference frame, the Earth is moving and the galaxy is stationary.
But can you understand how people who
the sun
don't
is moving and so on?
Right, but the only people who verify that are the people that, we're talking about convincing flat earthers. Flat earthers don't trust NASA and the authority. We're talking about proving it terrestrially.
So why are you?
And you can't prove it terrestrially according to George Ellis.
Why do you believe this mathematician then? Why do you believe George Ellis then?
Is that your best defense to that claim?
No, it just seems like you're cherry picking.
I'm not the one who believes it. You guys are, so of course I get to use it.
Well, I mean,
Wait a
just
minute.
think about it like this, all right? We can do a thought experiment then. From the Earth, we see the moon going around the Earth. If you're on the moon, you see the Earth going around the moon. Does that mean that either of you are wrong?
Actually, if you're on the moon, you wouldn't see the Earth go around the moon. You would only see it at high noon because we only ever see the one side of the moon. It doesn't spin around the Earth the same way the Earth spins around the sun.
Okay, then the sun, you would see the thing going around you versus here we see the sun
Wait a
going
minute.
around.
No. That's just wrong. No, you would 100% you would 100% see the moon or the Earth appear to go around the moon.
You're 100% sure about that?
I would say 95% sure.
Okay,
Because
so
I might
but you
something
realize
obvious,
we
but
only
yeah.
see the one side. We only see the one face
Yes,
of the
I'm
moon.
aware.
So
I'm aware.
that's the exactly. So that's the face that you see. You wouldn't see it's not spinning around. We're not seeing different phases of the moon. If we did, then you would see the Earth go
Oh
around.
no, that's right. Instead, you will see the sun go around the moon.
Right.
Yes.
So that's why sun instead, because I was thinking.
No, you're right. You're right.
So think of it like from the sun then instead. Again, just a thought experiment, right? Obviously, we're not standing on the sun for real, but from the sun you would see everything going around you versus on the Earth, it looks like it's going around us. Does that mean either of you are wrong? No, from your point of view, that's what you see. But again, it's just going to be relative to that thing, right? It's depends
Right.
on
The
looking
only
at it.
difference is that and I know that you feel that you can because you believe these authorities, but the flat earthers just do not believe these authorities that we
do I
can
believe?
detect the motion from the other reference frame. We only can prove the reference frame of the geocentric Earth.
What do you mean detect the motion or prove the motion?
Well, as Einstein even said, even after he invented relativity, he said, "I've been convinced that there is no optical experiment that can show that can prove the movement of the Earth, even though we know it moves around the sun." That's not me quote mining. That's the quote word for word.
You're right.
What's
From
the
the
quote? Hold on.
Earth, you can't, right? Like it's like pointing a radar
What's the
gun
quote?
while you're inside the car and pointing it at your friend who's also moving with the car. You're gonna get.
Hold on.
You're
Hold
gonna.
on. Can you read me the quote again?
Oh man, it was. I've since come to believe that there is no optical experiment that can detect the motion of the Earth, even though we know the Earth moves around the sun.
All right, hold on there. I found nothing on that quote.
Just wanted to thank you guys for answering my questions, and thank you to Photo Josh for letting me in for a couple minutes. Hope you guys have a good.
Quote minds Einstein's statement. Okay, first link is flatearth.ws. Second reference is Columbia. Okay,
Yeah, you can read
so
the full quote. It's fine.
Yeah, I will. I can also agree. Even Brian Cox has said it. Like when they're talking about the motion around the sun, how from the reference frame of the Earth you can't figure out that you're going. Like you have to look outside of that reference frame to figure that out. Like that. That is what they've said. I don't know about Einstein,
okay.
but I'm sure Brian Cox has said it.
So to be clear, when they're referring to an optical experiment, they're referring to using light beams in an interferometry way, like the Michelson experiment. That's what Einstein was referring to. It's earlier in the quote.
Can you read the full quote?
While I was thinking of this problem in my student years, I came to know the strange result of Michelson's experiment. Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect if we admit Michelson's null result as a fact. This was the first path which led me to the special theory of relativity. Since then, I have come to believe that the motion of the Earth cannot be detected by any optical experiment, though the Earth is revolving around the sun. The optical experiment he's referring to is the Michelson-Morley experiment.
I mean,
it's
he
literally
says,
in the previous sentence.
but he says the word any. I mean,
an optical experiment is not looking. It is an experiment using optics. He's referring to it's a very if you can't interpret that to specifically refer to the type of optical experiment that he was literally just talking about, I don't know I don't know what to tell you.
I mean, I can definitely look at it. I mean, I'm not saying I can 100% disagree. I'm just saying that he did say any optical experiment, and even there's other scientists and stuff who are also agreeing that it's all about the reference frame, like you guys are first saying, that you can't determine it.
Well, hold on, you can determine it, perhaps just not with optical experiments.
Well, no, the
you
only
can determine
thing
it by
so
measuring
far.
accelerations, for example.
I'm sorry, by what?
And I mean,
by measuring accelerations. You could determine that the Earth is rotating by measuring accelerations.
Accelerations of what?
The rate at which things fall.
I thought that was gravity. How does that have to do with Earth spin?
At the Earth's pole, if the Earth is perfectly spherical anyway, it's not, so you'd have to make some corrections. But for a perfectly spherical Earth, the Earth's gravitational pull at the north and south poles is stronger than it would be at the equator, assuming the Earth is spinning. If the Earth was not spinning, it would be equal everywhere. If the Earth is spinning, it would be lower at the equator than it is at the poles.
I mean, flat
And you can
earthers'
measure
answer
that.
to that is that because probably anyway, I haven't looked into this specifically, but the fact that the magnetic pole is going to be strongest at the North Pole, that there's electrostatic bonds that form all the molecules, and that we're dealing with dielectric incoherent acceleration. I mean, just saying there is another possible model for it.
All I'm saying is that this has nothing to do with flat Earth at all. All I'm saying is that there are non-optical means by which you can measure the motion of the Earth. In fact, that's what Einstein's general relativity tells us. Like, that is a direct consequence of general relativity. That acceleration is, it's not a direct consequence. You'd have to actually work out some details, but it's an indirect consequence.
And that's the main thing. Like when Brian Cox, for example, when he was saying that, they're just talking about the motion of the sun. Like just by looking at only the Earth, you can't just do
Things
that.
do way more at the poles.
The sun. Like we have
Sorry.
to look outside of us. For example, stars, phases of other planets, what constellations we can see, stuff like that. And then obviously you can send stuff up and literally do measurements, but at that point we're talking about something that not all of us can do. So basic stuff, we can figure it out. Someone said guest box. Who are we bringing in? Witch Doctor? Okay. Yo,
Hey-o.
what's going on?
Going on, Globeman?
Just hanging out, sitting here. Might have to pour a drink here in a minute. I gotta go get a cup though.
There's no way you're. What are you drinking? Probably a press.
By the way,
So,
thank you, Blitz and Troubling for keeping it respectful. I know sometimes these things get heated, so thank you guys.
For sure. Appreciate the
Yeah, Blitz,
platform.
Of course.
yeah, Blitz. I know you don't ever really get heated, but Troubling, since I've never
Apparently, that's what I'm known for here.
Yeah, it's always nice meeting somebody new, like Troubling, and then they're actually respectful. That's always awesome.
For sure.
yeah, you guys were mad about me earlier, though. I mean, again, Globeman, what are you doing? You were talking shit about me earlier because on Maria's live last night.
Yeah, Globeman. Talking shit earlier.
Hey, I do appreciate y'all's time, but I actually do got to peace out. I got dinner made. My wife's waiting on me.
All right,
So
do
anybody
that
wants
experiment that we talked about. Do it. Do the experiment. Come back. Tell me what you see. If you see what you expect, that'd be remarkable, and I'd change my mind.
For sure. Yeah, I appreciate you. I'll probably give you a little follow here in a minute.
Cool.
All right, y'all. Be easy. Be open-minded.
Take care.
I'll catch you next time.